Hello students, Namaste. Today we are going to discuss about osmotic pressure. It is one of the colligative properties for dilute solution. What is the meant by the colligative properties? Colligative properties means the properties of dilute solution which is containing non-volatile solute depends on number of the solute particles, but it does not depends on nature of the solute particles. Such properties is called as colligative properties. There are four colligative properties. First one, relative lowering of vapor pressure. Second one, elevation of boiling point of the solvent. Third one, depression freezing point of the solvent. Fourth one, osmotic pressure. First three we already discussed in my videos. Today we are going to discuss about osmotic pressures. Before the osmotic pressure, we are going to discuss osmosis. Osmosis. Look here. This is the solution 1. This is the solution 2. So this is semi-permeable membrane. Semi-permeable membrane. Short form SPM. The semi-permeable membrane contains small porous. These are the small porous. Porous means holes. Okay. Now, this is the solution 1, its concentration is a C1, solution 2 concentration is C2. So, C1 is the concentration of solution 1, C2 is the concentration of solution 2. Now, C1 is greater than C2. That means, solution 1 concentration is more than that of solution 2 concentration. That means, solution 1 is high concentration, it is higher concentrations. This is the lower concentrations. So this is a higher concentration means which is the excess here, solute is excess here. Which is excess? Solute is excess in solution 1. Here, solution to lower concentration means which is the excess here, solvent molecule is excess here. Solvent molecule is excess. Okay. So look here. Now we are going to discuss about size of the particles for solute and solvent. So the size of the solute particle is larger. Size of the solute particle is larger in size. The size of the solvent particle is small in size. Small in size. So the size of the solute particle is larger or bigger. The size of the solvent particle is small in size. Come to the point here. These are semi-permeable membranes. The membranes which is allows only solvent molecules through it but not allow solute particles. Such membrane is nothing but semi-permeable membranes. The membrane which allows only solvent molecules through it, but it does not allow solute particles. Such membrane is nothing but semi-permeable membranes. So semi-permeable membranes allows only solvent molecules. Why? Because the size of the porous is small here. The size of the porous in semi-permeable membrane is small. The size of the solvent molecule also small. That's why the membrane which allows only solvent molecules, but it does not allow solute molecules. Such membrane is nothing but semi-permeable membranes. Okay, examples: cellophane papers, parchment papers, and inorganic precipitate membranes, vegetable membranes. They act as a semi-permeable membranes. The example for semi-permeable membranes is cellophane papers, animal membranes, inorganic precipitate membranes, PPC. These are act as a semi-permeable membranes which allows only solvent molecule through it. Okay, come to the point. Osmosis. Here solvent molecule is excess, here solute molecule is excess. The momentum of solvent molecules or flow of the solvent molecules through semi-permeable membrane from solvent to the solution, or from dilute solution to the concentrated solution, or lower concentration solution to the higher concentration solution, is called as osmosis. Look here, osmosis means the flow of solvent molecules through semi-permeable membrane from pure solvent to solution, or from dilute solution to concentrated solution, or from lower concentration solution to higher concentration solution, is called as osmosis. Once again listen here, definition for osmosis: the flow of solvent molecules through semi-permeable membrane from dilute solution to concentration solution, or from lower concentration to the higher concentration solution, or from pure solvent to the solution, is called as osmosis. The example for osmosis is the plants take up water from soil through roots due to the osmosis. It is the best example for osmosis. Okay. Now we are discussing osmotic pressure. Look here. This is semi-permeable membrane. Here we have taken solutions. Here we have taken solvent molecules. Its pressure is P atmosphere. Its pressure is P atmospheres. This is a semi-permeable membrane which is used to separation of the two vessels. Its pressure is P atmosphere. Here pressure is P atmosphere. Generally, osmosis means the flow of solvent molecules through semi-permeable from solvent to the solution is called as osmosis. Okay. Now, the flow of solvent molecules through semi-permeable from solvent to the solution can be stopped by applying extra pressure on the solution. Here pi is the extra pressure. When you apply the extra pressure on the solution, what happens? The flow of solvent molecule from solvent to the solution can be stopped. Such pressure is nothing but osmotic pressure. What is the osmotic pressure? The flow of solvent molecule from solvent to the solution through semi-permeable membrane can be stopped by applying extra pressure on the solution is called as osmotic pressure. When you apply the extra pressure on the solution side, what happens here? The momentum of the solvent molecule from solvent to the solution can be stopped. Such pressure is nothing but osmotic pressure. Look here definition. Look here definition. The flow of solvent molecules through semi-permeable membrane from solvent to solution can be stopped by applying extra pressure on the solution is called as osmotic pressure. Okay. Osmotic pressure can be denoted by the pi. Osmotic pressure denoted by pi. Look here. Look here. The extra pressure applied on the solution to just stop the osmosis. Okay. So osmotic pressure denoted by the pi here. Okay. Look here. The correlative properties like osmotic pressure is directly proportional to the concentration of the solution. So osmotic pressure pi is directly proportional to the concentration of the solutions. So pi is directly proportional to the molarity of the solutions. Molarity of the solutions. So that means pi is directly proportional to capital M. Here capital M is the molarity. So this is the equation number 1. So pi is directly proportional to the temperature in Kelvin. This is the equation number 2. From equation 1 and 2 implies pi is directly proportional to m into t. So pi is equal to RMT. Here R is the gas constant. R is equal to gas constant. Now pi is equal to, M means molarity, it is one of the concentration methods. So instead of molarity, I will take here C or T. C means concentration of solution. It is for non-electrolytes. For electrolytes, pi is equal to I into C into R into T. Here I is want of factors, that is equal to number of ions. Number of ions from solute. Okay. Now look here. Pi is equal to C into R into T. C is the concentrated solution. Concentrated solutions. Okay. Look here. Solution contains solute and solvent. Generally solvent taken as A compound, solute taken as a B compounds. So pi is equal to M into R into T. It is also right. Yes. Molarity. Pi is equal to molarity formula in. That means number of moles of solute by volume in liters into R into T. Now pi is equal to number of moles of solute B is equal to weight of solute by molecular weight of the solute. So this formula substitute in this equation to get osmotic pressure. Pi is equal to weight of solute by molecular weight of solute into R into T by V in liters. Here pi is the osmotic pressure, WB be the weight of the solute, MB be the molecular weight of the solute, R is the gas constant, T is the temperature in Kelvin, V is the volume of the solution in liters. By using this formula, we can calculate molar mass of the solute. Okay, that means the molar mass of the solute can be calculated by using colligative properties like osmotic pressure. Okay. Now, isotonic solutions. A pair of solution having same osmotic pressure and same concentrations. Of solutions. A pair of solutions having same osmotic pressure and same concentration of solution is called as isotonic solutions. That means pi 1 is equal to pi 2. Pi 1 is the osmotic pressure for solution 1, pi 2 is the osmotic pressure for solution 2. That means That means C1 RT is equal to C2 RT. Here RT cancel, C1 is equal to C2. Look here, the pair of solutions having same osmotic pressure and same concentration of solution, such solution is nothing but isotonic solutions. That means N1 is equal to N2. So example, 0.9 percentage weight by volume of NaCl solution is called normal saline water. Normal saline water is isotonic with fluid inside human RBC cells. Human RBCs. RBC means red blood cells. Okay, that means here 0.9% weight by volume of NaCl is isotonic with RBC cells. Okay. Now, hypotonic solutions. Look here. The solution having less osmotic pressure and less concentration than the other solution is called as hypotonic solution. Once again listen. The solution having less osmotic pressure and less concentrations of the solution than other solution is called as hypotonic solutions. That means pi 1 is less than pi 2. If we place cells in hypotonic solutions, then the water will flow. Into the cells. The cells become swelling. Cells become swelling and finally burst. Look at when the cells present in hypotonic solutions, then water will flow into the cells become swelling. Such process is nothing but hemolysis process. Finally it is burst. This is about that hypotonic solution. Now hypertonic solutions. The solution having higher osmotic pressure and having higher concentrations than the other solution is called as hypertonic solutions. That means pi 1 is greater than pi 2. Pi 1 is greater than pi 2. If we place cells in hypertonic solutions, then the water flow out of the cells and they would they would shrink. Such process is nothing but plasmolysis. Look here, when the cells placed in hypertonic solutions, what happened? Water flow out of the cells. When water flow out of the cells, then what happened here? The cell would be shrink, minimize. The cell would be shrink means cell should be minimized. Such process is nothing but plasmolysis. Okay, this is today our topic. Thank you.